Yeah, thank you so much. So I'm going to talk about the future. And I have about 150 slides, so I'm going to do rapid fire for you guys, if you don't mind. But before moving forward, I want to go back to the future a bit, because we've been through a couple of very interesting and fundamental technological evolutionary steps almost in the past decades, with the first one being the introduction of the computer, the personal computer in the early 80s, where humanity was sort of introduced and connected to an intelligent machine. 10 years after that, with the introduction of the web in the early 90s, where individuals were connected with all sources of knowledge, was sort of the second fundamental technological evolutionary step. And then more recent, in the early 2000s, with the introductions of smartphones and social media platforms, we connected, at least we, billions of people were connected to billions of other people. And these three steps were amazing, and we still feel the impact of that today. But they were limited and restricted to function in the two-dimensional digital plane. And that is about to change. We are at the precipice of the fourth biggest digital evolutionary step. And I hear you think, I can see you think, what is that? Well, just imagine for a second that we can combine exponential technologies. At one side, for example, the incredible speeds of 6G, 5G, and beyond. We combine that with the power of edge computing. We can go to a world that we can paint with data, that we can see through the lenses of our devices, be it a smartphone, a computer, or a wearable. The data comes in real time from 1 trillion or more Internet of Things devices that are integrated in global society, in our systems, in our infrastructures, in our buildings, and us, at some point, in humans as well. This will allow us to go from a world where we actively need to look for data to a world that anticipates our needs and present the right data at the right time because we need it at that point. And if you look at all of the biggest investments in tech in the last, I think, nearly 2 decades, has been in AI, augmented and virtual reality, Internet of Things, blockchain, connectivity, but also things like 3D printing, synthetic biology, and edge, mesh, and fog computing. And I know that this is a little bit of buzzword bingo. I know that. But all of these technologies now are converging and are being woven into the fabric of society everywhere around us in the global civilization. So we are at the dawn of the impact that we will feel of all of these emerging technologies coming together. And at the same time, we are in an acceleration of both the technological possibilities as the adoption rate. So at one point we have Moore's law. Are you familiar with the terminology of Moore's law? Yes and no. It's a law that sort of writes the consistency that the numbers of transistors on integrated circuits doubles nearly every 2 years. So the amount of zeros and ones that a computer can do, the amount of calculations a computer can do. While at the same time, the cost of computers go down. As an example, the computer I'm presenting from, it's standing right here, it's a MacBook, which costs nearly 1,500 euros. 10 years ago, I could buy a similar MacBook for 1,500 euros as well, but this computer is exponentially faster because it's been through a couple of these cycles that the calculations can go up. So speed and possibilities will go up, and we will pay less per calculation. And also adoption is going up. This is years to 50 million users in the US. It took 46 years before there were 50 million users in the US using electricity, 26 for television, and only 19 days for Pokemon Go. And the speed this is going, just a thought experiment, is this exponential versus linear growth. So if I take 30 linear steps, of 1 step and a 1 step and a 1 step at a time, it will take me roughly, how far do I get? Anyone want to take a guess? 30 meters, 1 step, 1 meter, 1 meter. But what if I take 30 exponential steps into the one direction? Can anybody tell me how far I am then? Far, yeah. Nearly 26 times around the globe. That's the rate in which technology is progressing at this point. And that is also sort of underlies the limits of linear thinking, because as humans, we are hardwired to think 1 step at a time. We cannot think exponential. So therefore, we overestimate what will be possible in the next 3 to 5 years. We are heavily influenced by sci-fi movies, by the hype cycle, by presentations like this. The world is going to change. We can see flying cars and everything that's coming towards us. But at the same time, we underestimate the impact that these technologies will have down the line, possibly 10 to 15 years down the line. Take that into account if you look at the rest of the presentation of all of the examples that I will show you. So, what's next? Before we move into that, a little disclaimer. Looking into the future, predicting the future is incredibly difficult, so don't come knocking on my door in 10 years' time like, you were wrong, because I sometimes, well, often am wrong, but that's good, it's part of the job. But we can take an educated guess. You know? How this future will be named, I don't know. Age of AI, the metaverse, mirror worlds, contextual age, let's just keep it at the future. One thing is certain, we will have new relationships with digital content for consumers, for businesses, and for enterprise. We'll have new digital realities based on top of the websites that we use today. We'll have worlds nested in worlds and worlds and worlds and three-dimensional experiences that we can view through the devices that we already own. This will allow new, unique individual experiences from relaxed painting to music concerts, and this is already happening. If you look at the visitor numbers of the largest entertainment events in the world, for example, Coachella, Woodstock, the Rio Carnival, and Oktoberfest, and then a fortnight virtual concert of Travis Scott, where 27 million people watched the concert at the same time. The numbers just are mind-boggling. And these worlds now, the avatars that you use to interact with these worlds are now often cartoonish and labeled as childish, but they are changing into hyper-realistic versions of ourselves. This is an example from Meta Reality Lab, where they integrated sensors in a virtual reality headset that capture the muscles in somebody's face and translate that into a digital signal and use that to animate the avatar. The worlds as well are now often cartoonish, but they as well will be hyper-realistic, up to a point that we can no longer sort of see the difference between the real world and the virtual world. As an example, this is a GoPro footage from the Isle of Man most dangerous motorcycle race in the world. But it's actually not. You can sort of see that the motorcycle is from a video game, but the surroundings are getting so realistic up to a point that it could have been GoPro footage as well. So the question begs, will everybody move into these new digital realms after everybody on the PC, everybody on the internet, and everybody on the smartphone? The next generation is already there. 75% of children in the US aged 9 to 15 are active users of the Roblox platform. 75%. This is where they engage with each other, where they engage with brands. This is a place where they come together. This is our, MSN, what we used, or Hives, And those were like the virtual worlds where you can enter. And now something which is called the mirror world combines the world with the real world, where you see a combination, the merging of digital components into the world that we can see as well. So this is an example from Vario. Vario make a hyper-realistic virtual reality headset, a mixed reality headset, and in this case, a demo that they did for IKEA, where they project a really high-definition kitchen in somebody's space, and then you can change the colors of the cabinets, you can change the brand of the appliances, and you can just walk through and see how it changes around you. This is possible because of something that's called spatial computing. Spatial computing has been around for a while, but sort of marketed now by Apple as their thing around the Apple Vision Pro. It's the notion that the devices, they scan the world around us. They see depth, they see where a wall is, they see where the floor is, and they make a sort of digital layer on top of the real world that then can be used by digital experiences and apps to place digital objects and content on top of the real world. IKEA did an app like that in 2017. They were the first mobile app that launched by their innovation studio, Studio Space 10, in Denmark, in Copenhagen, which is now sort of standard. If you want to buy a TV on Coolblue or on Bol, you can sometimes place the TV in your living room to see how large it is. This was one of the first apps, so that's pretty interesting. But the notion is that content will extend beyond the limitations of the screen, and it will not be limited to two-dimensional content. It will be a combination of two-dimensional and three-dimensional content. And we're already seeing the first applications of this. This is an example. You have a floating two-dimensional screen. You can select the 3D object, and then you have the 3D object in your physical space that you can use your hands with to interact with, to make it larger, make it smaller. Just for educational purposes, this is amazing. This is the Mars rover. You can just look around and walk and see it. It feels like magic if you use something like this, And all of the big tech platforms are moving into this. This is an example from Mark Zuckerberg from Instagram, where he envisions a future where you have art and photographs in your space, but also digital content, some sort of virtual windows into a virtual world that you can do stuff with. And of course, Apple with their Apple Vision Pro recently, which focuses on productivity and stuff. But I think the big impactful thing of Apple Vision Pro came into an Apple announcement only a split second on the screen, which is something called spatial video, where they allow users with their new iPhone 15s, or maybe soon to be old, but to record spatial video. Essentially, that means that you can record a video, and then you can see it in semi-3D. My son was born 8 weeks ago, and I have a 2.5-year-old at home. I would love to be able to go back in time at some point to sort of revisit the moments that I am experiencing right now. This is a startup that just does just that. And the other day, I came across an indie developer who upskilled a video from his daughter eating breakfast nearly 20 years ago. This is a 20-year-old video. He upskilled it, and now he can see it in sort of semi-3D parallel effects. He can look at it, walk around, almost see behind his daughter and his son, which is absolutely amazing. And that sort of, maybe because I'm a new father. Yeah, I like this stuff, a bit sentimental. But instead of just having the two-dimensional screen, at some point you can wrap it around you, and then you can take a step into the world, and it completely immerses around you. That is absolutely incredible, and it opens up a plethora of new possibilities for brands who are experiencing with it. This is from the Brooklyn Nets stadium. They have retrofitted their existing stadium with volumetric capture cameras. So essentially what that means is that they can capture the game in real time in 3D. So you can project the game on your coffee table and see holograms of the players walking around doing the game. Or you can just walk on the pitch in a VR experience and just experience the game being played around you in real size. And you see the first things like this coming to life with the Apple Vision Pro. They did there's a small startup called Immersive.io. They did this for football. You can just have a projected holographic display of the football match in real time. You can tap on players, get more information and data about the players. It sort of completely transforms the entertainment watching industry in the space. One of the key elements of using these headsets and devices is hand tracking, because the sensors on the device need to be able to accurately track your hand so you can interact with these digital components. And that is going on for a long time. This is a video from, I think, nearly 8 or 9 years ago. And object tracking as well. In this example, the ping pong ball is not real, but the bat is. But the digital content, the ball, adheres to the laws of physics as well, with gravity and the force of which is being hit. And the other person on the other side is actually in another country. That's also a nice element. This is filmed with a GoPro in a device, so it's very accurate. But we'll go to a world where we can interact with holograms. And if you've never tried that, that is really magic. It's almost like being Iron Man, being able to, swipe through devices, or what's his name, Tom Cruise in Minority Report, using his hands to go through digital screens. But this is already possible today with some of the headsets that we have. And we'll see more and more of this coming forward. Let me just click. Yeah. Of course, this is not something that happens overnight. It takes years and years of prototyping and research. This company, Magic Leap, back in 2013, 2014, they got a almost 3.5 to 4 billion euro, $1 billion investment based on this device, it was very secretive. Nobody knew what it was, but they got 3.5 billion for it as investment. It's like a thing that you go to the eye doctor, you put your face in, and then you can see things. But now they have a device which is as small as this device. And at the same time, you see a lot of indie developers and designers trying to figure out and wrap their head around how do new user interfaces look like for a world where we can interact with digital content with our hands. So you see all these very interesting, small little niche user interfaces come to life, which is great. But these devices are now often big and bulky. I mean, the Apple Vision Pro itself, it's heavy. I don't see myself using it for a very long time. I will go to a world where it is small, sleek, elegant, and integrated in all of the glasses that we already wear. So people who are already wearing glasses, we're at an advantage. We have to wear glasses anyway. This is made for us, finally. This is a video I came across from when I ran an innovation lab in London back in 2014. We sort of tried to envision how a virtual interface would look like in the real world, and now Apple came with their interface, so I say that we did a pretty good job back then, nearly 10 years ago. Sticking with the Apple Vision Pro, their interaction model is not with hands, sort of is, but the main thing is with eye tracking. So you can use your eyes, your iris, to select something, and it works very, very well. And then you can tap your fingers to actually select buttons. And this is great. It's very intuitive. But at the same time, eye tracking is potentially very dangerous, because the amount of personal information you can extract from somebody's iris is immense. If you think that Cambridge Analytica was bad with Brexit and Trump, based on all of the data they had on people, surfing the web and browsing their social media and posting and commenting and stuff, wait until they have information about everybody based on their eyes. That's just scary stuff. But researchers recently have found, there's this one, that they can also figure out where somebody is looking based on the sound from their ears. Essentially, if you wear earpods, they can measure the sound your eye makes if it looks at something, and they can very accurately figure out where the eye is looking based on sound that's coming out of your ear, which is, pretty sci-fi stuff. But that's pretty cool, because then we don't need the sensors, the cameras and the sensors right in our face and extracting all of the personal information. Anyway, for spatial computing, I guess it will take a while before we see mass adoption. We're still on that sort of innovator/early adopter phase, and it will take a long time before these devices will be cheap enough, powerful enough to be integrated in, the glasses that we want them to be. But it has been a long time coming. This is the first patent that Apple filed back in 2014, which is now the Apple Vision Pro. So, 10 years down the line, they release a product, and they've been working on this for a long time already, probably even before they launched, they filed for the patent, of course. At the same time, in the meantime, brands are preparing for a world where we see more and more of these devices. You should too. You see creative augmented reality campaigns where they create a digital layer on top of cans to make a digital experience. But at some point, we will have a digital layer on top of the real world, a digital twin of the world, with something that's called a visual positioning system. Google is very heavily investing in this. So you can just use your camera, and it identifies the buildings around you based on the digital twin, the digital copy that they have of the buildings, and then it knows where you are, and then it can be used for something like persistent information, geospatial augmented reality experiences, that everybody in the stadium can see the same things about the players in this regard playing the game, but then from different angles. This is a demo from a baseball match in Korea, where everybody in the crowd is able to see the wyvern flying around based on their unique position, because they've made a digital copy of the entire stadium, and the dragon is, the wyvern, sorry, is digital. And it just allows everybody to experience the same thing from their unique perspective. We'll see a digital twin of the world, which is already being used, one, by NVIDIA. They made a digital copy called Earth 2. They're actually releasing it pretty soon. They've been working on it for a while. Their CEO announced it 2 days ago, which is very interesting. They made a copy of the world to study climate change and the effect of hurricanes and typhoons and these kind of things. Microsoft is using their digital twin of the world, which is also used by Flight Simulator, which is a direct copy of the world, which is interesting, and you can upload it with live data. So if there's a storm over the Atlantic in the real world, there's also a storm in the Atlantic in Flight Simulator. I think that's pretty cool. But they use it to train the software for their drones. And Tesla is using similar technologies for the training of their AI in their self-driving cars. Next, of course, to all of the data that they extract from all of the cars that are driving around. But in a world like this, they can simulate everything. I need it to rain. I need to be the lights coming from this angle. I need it to be wetter. I need to be more cars, more pedestrians. You can just click the buttons, and then stuff happens, which is very cool. And you can do thousands of hours of training in mere minutes. And it's already widely used in factories, from Amazon, ranging from Amazon to BMW to all of it. I'm not going to go into that, but it's standard practice in a lot of the creation of factories as well. I went from digital twins of the world, let's go back down to the digital twins of our faces, because that is probably the augmented reality that we are using the most. If you ever use a Snapchat filter or an Instagram filter on your face, maybe not the crowd, I see some people not, but not everybody, that's essentially the same thing. The device makes a three-dimensional digital twin of your face, and then it projects a augmented reality experience on you, whether it's makeup or a silly face. And the technology is getting a lot better. Question, are these real glasses or is this fake? Of course, everything you see in my presentation is fake. Disclaimer, you know? Or is it? One side of this person, and of the other person you'll see in a second, is real, and the other side is an avatar. Can you decipher which side is real and which side is not real? No. And no, they're not both not real. One of them is really real, I know that. His left ear, so for our right, is a little bit more grainy. This side is real, and that side is fake. But it is very, very close. And this is Mark Zuckerberg explaining that their avatars are getting photorealistic, and on the right side you see that you really can zoom into all of the pores and the wrinkles, and it's getting so close right now, these virtual humans. And it is accessible for almost everybody. The software to create these virtual humans are freely available. And at some point we don't even need these software to do this anymore, because this is recent research from Microsoft where they take one photo and they're able to completely animate that one photo into an avatar, talking about, I don't know, to your customers if they have a question. So these people do not exist, but there can be brand ambassadors for your brand. And that's already happening. You know, virtual influencers. I found a really interesting statistic about that, is that follows at least one virtual influencer. The age group 18 to 24, 75% of them, at least in the US, follows at least one virtual influencer. My age group, right in the middle, I don't know if I follow a virtual influencer. Maybe. Maybe they're so good that I don't know. But a lot of people do follow them, which is interesting. I would doubt that my parents would know if they follow one. But they can speak every language. You know, that's not a problem for them because it's an avatar. And this sort of brings me to the big AI revolution that we've been talking about for the last 2.5 years. I know that a lot of topics for today are also about AI. But let's just touch on that for a second. Generative AI, I guess everybody works with Gen AI right now. Do you? Yeah. Yes, okay, that's good. So I don't really need to explain what it is, but complex context from textual input. As an example, let's make a photo, an astronaut riding a horse in a photorealistic style. What happens is that you put in the prompt and an astronaut, and it starts to figure out what is the meaning of an astronaut. It sort of gives direction to the background, because obviously astronauts need to be in space. Then writing, what's the position of the astronaut? Does it sit? Does it stand? The horse, what's the relationship between the horse and the astronaut? And then the style, how do we need to present it? And then you get something like this, which is pretty close. But this is actually a picture that's nearly 1.5, nearly 2 years old, one of the first pictures from DALL-E 2. If you run the same prompt through generative AI image generation models today, you get something like this, which is a lot more accurate and a lot more high realistic and high definition. But you can do fun stuff with Gen AI as well, because I was wondering, I'm a bit of a history geek as well, how would GoPro footage look like from the French Revolution? Something like this. I wasn't there, but it looks pretty accurate. A bit bloody, maybe, I don't know. But this space is moving just as fast if you take a look at the exponential curve as other technologies, maybe even faster. This is the same prompt in Midjourney with a 2-year difference. See how advanced the AI has become? It's really, really high definition girl instead of the weird contraption that we had before. And it's up to a point right now that personally I cannot see the difference anymore between a real photo and a photo that's being created by AI. If the prompt is good, that's very important as well. And the latest developments is that we can start to animate these images as well. This is a video prompt. From, I think, 8 months ago. Dashcam footage of a car driving in an interstate somewhere in the US. It's pretty grainy. You see that it's sort of built up layers of pixels. But if you do a similar prompt right now, you get something like this, which looks really realistic. And this you can alter in real time. You can just edit the prompt while the car is driving. I want the sunlight to change. I want to be more pedestrians, more cars, which is insane. So this begs the question, can we sort of trust dashcam videos anymore? In court, for example, if something happens. That's a bit scary as well. This is from OpenAI, their latest video model. This is created from one prompt. One piece of text input created this video, which is very sort of discerning, but also very interesting. And this sort of comes up with the question, do we need fake catchers or digital watermarks that we can identify whether something is created by an AI or not? Intel says that it made something with a 96% accuracy, which is in fact less than 20, I guess, maybe even closer to 5 than it is to 20. You know, because the space is moving so fast. We are in this massive AI acceleration because it's accessible for everybody, and there's a reason for that. But before I get into the reason, this is days to 100 million users globally. You see, compared to Netflix and X and Twitter, Spotify, Facebook, ChatGPT just is a straight line up in terms of adoption. And the reason why we are in this acceleration is that before, there were multiple AI domains. You had things like robotics, voice creation, sound, image generation, computer vision, and if there was a scientific breakthrough in one area, it did not directly translate into a scientific breakthrough in another area. But about 2.5, 3 years ago, there was something that's the realization, which the great consolidation, where researchers figured out that all of them had a common denominator, which is language. So language as the common denominator allows us to have, the text on the web, text on the internet, but also things like DNA, 4 letters, code, images, which is RGB, robotics, it's just a set of motion that you can directly translate into language. So now, if there is one breakthrough in one area, it directly translates into all of the other areas as well. That is sort of underlying why we are now seeing the acceleration, even speeding more up than it was before. Will it be bigger, or the impact bigger than the invention of fire? I don't know, I guess time will tell. A little bit technology behind the magic. How does an LLM work? I'm not going to quiz you on this, but very high level. They learn to recognize patterns between the words and predict the probability of the next word. So if you ask a question to ChatGPT and it just spams some text back, all of the words, all of the letters are being predicted, what the probability is, whether that's the next one in the sentence. Really, really fast. They understand the combination of words, the context around it, the semantics, and they convert that into tokens. So if I talk about a beautiful day on the beach with sunny sky and a nice day with my kids, and I ask what color was the sky, it will probably say the sky is blue, and then there are numbers behind it. That's because of the mathematics behind it. The more tokens available in a model, the more context can be included. So the more semantics and the more body around a question. And then the more computing power, this relates back to Moore's law, the faster these models can operate. So how does it work? The sky is, what's the sky? And it goes into the magic box. And then it figures out it can be clear, it can be average, it can be the blue, but blue is the most probable, so therefore the sky is blue. Very simplistic view on how something like this might look like. But the same is for pictures. Pictures are built out of pixels, red, blue, and green. So it calculates the probability of what color the next pixel will be. And therefore, it sort of pixel by pixel creates these images if you run an AI image generation model. The same for videos, but then on a much larger scale, because every frame is built out of pixels. And really, really, really fast behind the scenes, they just calculate every next pixel, and then together that is a video. And therefore, you can do everything with text to ... Text to video, text to images, avatars, 3D, video games, augmented reality, but also more so sound is a new thing. And everything, because there are a lot of low-code, no-code tools that you can use to just integrate this into your workflow. And that's where it becomes interesting for those who cannot develop themselves. But I need to stand for a minute on the bias problem, because AI has a huge bias problem. For example, if you ask an AI, or in this case, Midjourney, the most beautiful woman in the world, you get a white woman with blonde hair. Or a CEO of a large company, you get a white guy. It's very difficult to get the bias out of the systems because it's been ingrained in the data for a very, very long time. Fortunately, newer models, they are improving. So that is good and worth mentioning. Especially because we'll see more and more ways that we interact with these models in our daily lives. We're going from Googling, like we know now. You put in a query, and Google searches for the keywords, and you get a list of links, some ads. Before you know it, you have 25 tabs open in your browser, and you store all of the information in your head, and you're trying to figure out what the answer is. So just ask the same question, and the model will do all of that research for you It tells you which sources it has used, and it just spits out the answer, which is great. Is it great? Because again, Google is integrating this, and it gives some weird answers. Because it does not only use verified data, it also uses stuff from Reddit and other places. So we have a long way to go before this is going to be accurate. And Google becomes your AI agent. This is something that they hope to roll out next year. So for example, you can ask it just directly in Google Search, my family and I are going to Miami for Labor Day, my son loves art, my husband wants seafood, can you pull my flight and hotel info from Gmail and help me plan the weekend? And then behind the scenes, Google activates all of these AI agents, and they go to work. They make the reservations, they plan your itinerary, and they make this huge map, and they just give it to you in the list, and you can add stuff and change stuff. Oh, I don't want to wake up at 9, I want to wake up at 11, I want to sleep in. And then the whole itinerary changes. So they put a lot of AI agents, small little bots, to work for you. And we see new models being released, it looks like almost every single week. And they focus on speed and efficiency, so more calculations. Multimodal reasoning, so not only using text input, but also using video input and sound input. You can talk to these devices, much like the movie Her, of course. And larger context windows, so more tokens that are available. And emotion is starting to matter. This is a new thing as well, which is incredible. So before you ask, for example, ChatGPT, tell me a joke. And it tells you a joke. But if I ask it to tell me a joke while looking at the camera and speaking with my voice, and I'm maybe a bit, sad or down, it will pick up on that. And it will tell me a joke based on how I feel about my emotions around that. You seem down, are you all right? Here's a joke that might cheer you up. But even if you build custom agents before, for example, a Spanish language tutor agent, this could be sort of the high-level prompt. Your objective is to teach me Spanish. I will say something, and you will respond in Spanish. Keep it conversational. But now you can add stuff around emotions to it to say that if I sound or if I struggle to pronounce something, try correcting me first. If I'm grammatically wrong, correct my grammar. Keep aware of my tone. I get frustrated. So these things will start to play a role in how you interact with these models moving forward. That's a new aspect of interacting with large language models. And there are a lot of companies in this space right now. This is a snapshot from March. And this is also growing exponentially. It looks like every single day there will be new icons added to this list. At the same time, it's very important that all of these companies adhere to responsible AI. So be anti-bias, be transparency. What data have you used? Be inclusive to all of your users. Privacy by design, accountability, and human-centric. Pretty straightforward, but not implemented by every company. You could say that the generative age is upon us. If you talk about to put a name on how this future might look like, but I would argue that we're already there. It's already here. This will change expectations. Not only from average users, but also from employees, because people start to expect that their employers fully embrace these new AI tools. They want to work with them. And I think that the mass adoption for generative AI will definitely happen sooner than spatial computing, for example. Soonish, probably faster than I think. One thing is for sure, though, is that it will definitely change the way that we interact with digital, if you combine those two realms. So one, everybody will have their own virtual layer. We can see the same thing, but it will be different based upon what I want it to look like. And secondly, everybody will have their own army of little Einstein AI agents doing work for you. There are people who predict that within 10 years, there will be more AI agents browsing the web and interacting with each other than there are humans browsing the web. You could see the future where my AI agent, if I'm planning a trip for a summer holiday, my agent is talking to the agent of Booking.com, to KLM, for Airbnb. You have all these agents in the background talking to each other and trying to figure out what needs to be done, which is pretty interesting. But how these changes will change the way that we interact with digital, and especially with each other, is yet to be seen. We don't know that. So especially if you look at the overestimating versus underestimating the future, we don't know what the impact will be 10, 15 years down the line. So that's very interesting to keep an eye on. At the same time, it's our responsibility for both the companies that make these models, but also the people who work with these models, aka you, to do so responsibly and think about what you're doing and why you're doing it and keeping it, ethical, responsible, and so forth. I want you to sort of main takeaway is that the possibilities with these exponential technologies really are endless when you combine these technologies. And I've only touched on spatial computing and AI, avatars a little bit, virtual worlds, but not synthetic biology or other things. So it's crucial to continuously start to learn because this space is moving so incredibly fast, and especially if you want to look at how the impact will be in 10, 15 years down the line, and the impact for you as a person or for you as your business. Very important. And 45 minutes is not nearly enough to cover everything that is happening. It's just the tip of the iceberg, the tip of a massive underground iceberg. But I want to write some key takeaways. Capabilities are accelerating exponentially. We mere humans are not hardwired to think exponentially. But it is very important that we try to do so. The physical and the digital world are merging. And virtual objects will be indistinguishable from real life, from real objects. AI will be integrated in nearly every aspect of our lives. Behind the scenes already happening, as you might already know, as you probably do know. And then last but not least, continuous learning is, when we design and building for AI, we need to do so ethically and responsible. And last but not least, continuous learning is absolutely crucial. And with it, I want to thank you for your time. Thank you for inviting me. And back to you.